Hello, this is Ms. DB. In this video, I'm going to look at number 4 from your worksheet on logarithmic functions on transforming log functions. So look at this example. It says graph each log function, log is short for logarithmic, then find the asymptote, then describe how the graph is transformed from the graphs of the parent function. Let's put the graph of the parent function on here. The natural log parent function would just be of x, whoops, I have Desmos open, equals natural log ln of x, so I'm going to graph that. And then I'll also graph the common log. I will call that, I'll call it h of x. I don't know that I need this for this problem, not for a and b, but maybe for, and that's just log of x. And I'm going to hide this one by clicking on the color circle so you just see natural. Maybe I'll just even put this on later. Okay, so here's the natural log of x that we need for a and b, and how I know that is because they both are using the natural log in the equation, in the function. So I'm going to graph this function at the same time as this function is graphed, and then answer some questions. So in the example, it was negative natural log of x minus 4, and that is the red graph, see? And here's the natural log that we also have graphed. And you can see that the asymptote of the red one is x equals 4. It's going to get close to but never cross that vertical line. And we can see that it has a couple different transformations. It's moved over, so it moved over 4 units, and it also reflected about the x-axis, so it's upside down. We can also tell that from the equation because the negative means it's reflected over the x-axis, and the x minus 4 means it moves to the right 4. These transformations are just like when we looked at transformations of quadratic functions. It's the same kind of idea. So and then there's another example with the natural log. Let's do letter A, and then you can do B by yourself. So I'm going to type in g of x equals the natural log ln of x minus 2. Want it in parentheses, I just want it just like that. And I'm going to turn the color red so I can see it easier, because the blue it's kind of hard to. So you click on, I clicked on this edit button, then click on the color, then click on the color, and then I'm going to pick red. And now it'll be red. There, now it's red. It's easier for me to see it. Okay, so I can see what's happening here. What's happening? It's still increasing. It has not been reflected over the x-axis, but it's moved. It's translated. And I can tell from the equation that it went down 2. So look here, this was at 1, 0, and this is at 1, well, it won't let me get the exact, but it's 1 negative, oh, I had it for a second, 1 negative 2. So I can see that from 0 to negative 2, it moved down 2 units. So I am going to find the asymptote. The asymptote did not change from the natural log of x. And that's the same asymptote that you did when we did number 3, I think it was. But you didn't have to write the asymptotes for that one, I guess. But the asymptote is that x is equal to 0. It will never cross that line. The transformation is that it went down 2. I suppose I can write that it's a translation. But I wouldn't mark it wrong if you just wrote down 2. And now I need the graph. So you can either take a screenshot of the graph, or you can get a link to the graph by using the Share Graph button. It in, and don't forget to hit a space bar 1 time afterwards so that I can click on that. And then you're going to do B, which will be very much the same thing, except the translation will be in a different direction. And you also might have the asymptote might move. Let's look at this, and then I'll let you write the answers. So the blue is the original parent function, and this one moved over. You can see it is a translation, and you're going to write whether it went left, right, up, or down, and how many units. And then the asymptote is no longer x equals 0. The asymptote's right here. So what is that? X equals, and you're going to figure out that answer and put it in, and then you'll add a link to the graph. And then in C and D, it's very, very, very similar. Actually, D is also using a natural log. C is using a different parent function. C is using the natural log, which is log instead of ln. G of, oh, it's f of x. Actually, I'll put it in the parent function first, log of x, and then I'll put in this equation. I'm switching the f of x and the g of x, it doesn't matter. And this is log of, and then we need the parentheses, x plus 5. Zoom out so I can see what's happening here. Okay. Wow, that looks really different. What happened is the asymptote is over here now. It moved over, and then it really quickly goes up and then flattens out. So did the blue one is the new. Did it move up, right, left, or down? And by how many units? And then the asymptote will now be over here. It'll have x equals something over here. You can probably tell what it will be. And number D, or letter D, will be like that. If you didn't already do 5, all you need to do is graph them in Sketchpad, I mean Desmos, or Sketchpad if you have it, and then decide which one of these shows the correct shape of the graph, which one would be correct. So do your best on that. Okay, that was just a quick one to mostly work on the transformations in question 4. Thank you.